Welcome students. Myself Dr.Monika Khetarpal. I am Associate Professor of Physics in Government Dungar College, Bikaner. Today in my virtual lab, I am going to discuss an experiment on non-inverting operational amplifier. We will perform this experiment virtually using LTSpice. Before starting our experiment, I am going to tell you something about non-inverting operational amplifier. This is the basic circuit diagram of non-inverting operational amplifier. Operational amplifier consists of three terminals. Two are input terminals. The one denoted by negative sign is an inverting port, and other denoted by positive sign is non-inverting port, and this is the output terminal. We are in require of two resistances, that are input resistance and feedback resistance. This is my input resistance and this is the feedback resistance, which is denoted by RF. Here we are using negative feedback. We are giving our input on the non-inverting port, that is on the positive terminal of operational amplifier. The gain of this non-inverting operational amplifier is output voltage divided by input voltage. Gain indicates the factor by which the output voltage is amplified, and the gain tells us how many times the output voltage will be than that of input voltage. The gain of non-inverting operational amplifier is 1 plus RF upon Rn. That means the gain depends on the value of the two resistance. These two resistance decides the gain of an operational amplifier. So students, now let us begin with LTSpice. This is the circuit diagram that we will finally make. Now suppose I am expecting a gain of 10. That means we have to choose our feedback resistance and input resistance so that gain, which is output voltage divided by input voltage, is equal to 10. Here the input resistance is shown by R1 and the feedback resistance is shown by R2. Now I am taking my feedback resistance to be 9 kilo ohm and this is my input resistance, which I am assuming to be 1 kilo ohm, so that my gain will be equal to 10. And as we know, op-amp is an active device, so we need power to input it. I am giving a supply of 15, and as we are designing a non-inverting operational amplifier, we will give input on the non-inverting port. Here we are giving an input which is a sine wave. So this is the basic circuit diagram that we will finally make. Now let's start to design this circuit. Here we are using LTSpice and choosing new schematic to draw this circuit. So let us begin to choose our components. First of all, I am choosing operational amplifier. I will choose universal operational amplifier to design the circuit. I am placing the operational amplifier in the desired position on the board. Now I am going to choose the other required components. The other required component is resistance, First of all, I am choosing the resistance which is input resistance. I am in need of another resistance which is a feedback resistance, which is shown here by R2. So I have taken my two resistance. Now I will choose the voltage sources that are needed. The first voltage source is applied to the non-inverting terminal of the operational amplifier. It is shown by V1 in this circuit diagram. Now I am choosing the two voltage sources that are needed to power the operational amplifier. The first voltage source that I have taken is shown by V2. Now I am choosing my other voltage source which is shown by V3. This is my another voltage source. Now I am going to make the connections of these components. The first connection that I am going to draw is the connection between inverting terminal and input resistance R1. The next connection that I am going to draw is the connection between feedback resistance and the input resistance. The next connection is the feedback resistance is connected to the output of operational amplifier. Now I am going to connect the non-inverting terminal to the input voltage. This is the basic circuit that is required for non-inverting operational amplifier. Now, since op-amp is an active element, it requires a power for it to work. Hence, we have to connect it to the voltage sources. Now I am connecting my operational amplifier to the voltage sources. This is the connection between op-amp and the voltage sources that power this op-amp. Now the left connection is the connection of ground. So I have to ground the remaining terminals that are free. I am taking ground to make the connection of non-inverting terminal voltage to the ground. I am making the connection of ground to the power supplies that are connected to the op-amp the connection will be made of ground to the input voltage, and the left connection is the ground to the voltage source V3. So students, this is the desired connection that I have made for a non-inverting operational amplifier. Now we have to assign values to our components. The first component is resistance R1. Let the resistance R1 to be 1 kilo ohm and the feedback resistance R2 to be 9 kilo ohms, so that we have a gain of 10. Now I I am giving my operational amplifier a supply of 15 volts. A DC value of 15 volts is assigned. Now the input voltage, which is on a non-inverting port, let it be a sine wave, and we are taking our amplitude, input amplitude, to be 10 volts, 10 millivolts, and frequency to be 50. So we have an input wave which is a sine wave which has an amplitude 10 millivolts. Now our circuit is complete. Now we are in a position to run our circuit. Let our stop time to be 1. Now we are going to simulate our circuit. Let us first check the input. We can see that on touching it on a node, our cursor has become a probe, and this is my input signal which has an amplitude of 10 millivolts. Now we will check our output. This is our output. We can see that output is also a sine wave, as input is also a sine wave and output is also a sine wave, and here it is clear that output has an amplitude of 100 millivolts. So the gain factor, which tells us how many times the output voltage will be then the input voltage, is 10. That means the input voltage is amplified by a factor of 10. Here we can clearly see that input and output voltage, they are in the same phase, because the gain of non-inverting amplifier is positive. Hence, both they are in the same phase. Now, let's make a change in the input signal. I am changing my input signal from sine wave to have a DC value of 1 volts. So, this is my circuit now. Now I am going to run my circuit in this position. Here I am checking my input signal. As it is shown on the graph that my input voltage is 1. Now I am checking my output. We can clearly see that output is 10 volts, because we have a circuit in which the factor of gain is 10. So whether we are giving input in the form of a DC signal, simply 1 volts, or in the form of a sine wave, we have a gain which has a factor of 10. Now I am making another change in my circuit, in which I am changing the supply of op-amp, which I have taken to be 15. I am changing it to be 5 volts. Now let's see what happens. Here the gain we have taken to be 10, and the supply voltage is less than the gain which we are expecting. Now let us run our circuit and simulate it to clearly see what happens. We can see our input voltage is 1 volts. Now I am checking my output voltage. Here we can see that output voltage here is simply 5 volts, but we are expecting our gain to be 10. So our output can never exceed the real voltage of op-amp. Hence, to power an operational amplifier, we should give the voltage which we are expecting the gain to be greater. For example, here when we were expecting a gain of 10, we have taken the voltage to be 15. That was appropriate, and we have shown that if we give a voltage of 5, then we will not get a gain equal to 10. Thanks a lot for watching.